Hello to friends and colleagues attending the SCL CCFFR conference. Alain Patouan speaking from beautiful Shippagan in the Acadian Peninsula, situated in the northeastern part of New Brunswick. And today I'd like to talk a bit about two coastal catchments I have been studying over the past few years with my colleague Céline Surette at the Moncton campus. So here are located the coring stations I'll be talking about, the Richibouctou catchment and the Cocagne catchment. So as in my previous talks, I'm generally and fundamentally concerned with variability, ecosystem variability. Basically, I'm interested in figuring out how we can describe ecosystems, how we can describe nature, how these descriptors vary through time and through space, and trying to figure out if this variability can be related to causal factors. Here I'll be examining hydrological position, land use, climatic variability. More precisely, I'll be talking about long-term variability, variability throughout the 20th century, and for this paleoecological studies are useful. By taking sediment cores, we can reconstruct the history of various ecological, biological indicators and relate them to historical changes. For example, what we typically observe for big estuaries, for big coastal catchments that are heavily populated, for example, in the Chesapeake Bay on the eastern coast of the United States, what we observed often is that from the pre-industrial times to the present day times, we often observe increasing concentrations of algal abundance or bacterial abundance, often in an exponential way. And parallel to these increases, we can often observe increasing urbanization or increasing agricultural activities. Here we show human population of the Maryland state or consumption of fertilizers. And the idea is that, well, both are obviously correlated. The idea being that the more fertilizers are applied on coastal catchments, the greater the export of these fertilizers to aquatic ecosystems, where they will fertilize and promote algal growth. So again, this is the case for heavily populated coastal catchment. What is the case for smaller or less populated areas? Do we observe the same obvious trends at the 20th century scale? I'll be talking about two coastal catchments along the Northumberland Strait, the bigger Richibouctou catchment and the smaller Cocagne catchment. In both cases, we have three coring stations, and I'll be always talking about them in the same order, going from the upstream to downstream from the most the most freshwater sites to the least or most salty site. So upstream we have the Saint Nicolas River. After we have the Saint Charles and the Rexton station. The Rexton station is about at the same salinity level as our upstream Cocagne core, and then the midstream Cocagne core, and we have Outer Bay core also at high salinity levels. So these two coastal catchments are typical of the Northumberland coast of New Brunswick. There is a lot of estuaries located on a rather flat landscape and that have been that have experienced changes throughout the 20th century with respect certainly to agricultural activities, often with a peak in the 1920s or 30s, a certain degree of industrialization, and certain increasing human population densities, but again not to the same extent as can be observed in other parts of the world, namely the US coasts, Europe and Asia. So the question here again is to know whether in least impacted regions of the world, how did metal contamination and algal abundance vary throughout the 20th century. Let's look at how some metals have varied over the 20th century. I'll be showing on the y-axis years from present day times to the end or the mid-19th century, and on the x-axis various concentration of metals. Here I'll be talking about mercury. So if we start with the most upstream site in the bigger Rishi-Bukto catchment, we can see basically generally decreasing, a stable and then peak in the 2000 and a decreasing trend, the decreasing concentration of mercury. Moving downstream, still staying in the Rishi-Bukto catchment, we have this much lower concentration, but again a tendency to decreasing concentration during the last decade or so. And again, moving downstream, pretty much the same pattern. Now, it must be noticed that the difference in concentration between these sites is partly explained by sediment granulometry, with upstream sites being composed of finer sediments, allowing for greater surface area for metal absorption, and the downstream sites are characterized by coarser sediments, so less adsorption surface per gram of sediments. Now if we move on to the smaller Cocagne catchment, starting upstream, we see pretty variability, and again moving still downstream, somewhat maybe increasing, maybe an increasing trend, and again downstream in the bay, in the open water, clearly in an increasing trend with a recent peak and decreasing concentration thereafter. Turning to indicators of phytoplankton abundance, we look at beta-carotene, which is an indicator of total algae in a nanomole per gram of organic matter. Again, in the bigger Rishi-Bukto catchment, we can see basically declining trends. Certainly lower concentration after the 1950s than before. Certainly for the upstream and the midstream site, maybe less of a tendency for the most downstream site. A curious synchronous dip in the 1950s that remains to be explained. If we move on to look at the smaller Cocagne catchment, we see variable or slightly increasing trends, maybe except for the Cocagne Bay displayed here, where we can see decreasing trends. Now, if we look at an indicator of cryptophytes in the alloxanthine pigments, we show a reverse, a trend that is opposite to that of total algae, in that concentration seems to have been increasing, at least since the 1960s or 70s, certainly in the bigger Rishi-Bukto catchment and also in the upstream sites of the Cocagne catchment. Again, here there's only the Cocagne Bay site that shows a reverse trend in showing declining cryptophytes concentration. Now, can these temporal patterns in metal contamination and algal abundance be related to land use factors or climatic factors? I'll first show how general indicators of land use have been varying throughout the 20th century. Here I show for the Rishi-Bukto catchment, the bigger Rishi-Bukto catchment, human population density, inhabitants per square kilometers for the upstream reaches of the catchment. And what we see here is very typical of many New Brunswick coastal catchment, in that human population reached maximum values in the early 20th century before declining in the 50s up to present day time. Now, this is not universal. If we look at other reaches of the coastal catchment, here I show a downstream reach of the Rishi-Bukto catchment, we see an increasing trends. So it can vary depending on what part of the catchment we're considering. And notice also that the values here are extremely low compared to what can be studied in on the US coast, in Europe or Asia. Here we're at values 50 to 10 to 20 times lower than what is typical in other regions of the world. So very low human population densities. Now here comes the tricky part. Can we relate temporal variability in metal contamination or algal abundance to indicators of land use or climatic variability? It's very easy to detect some correlations when we have a big data set, and certainly here we have been collecting data on many variables, on many land use variables. We'll be collecting variables on climatic indices also. Here I show one example of a good correlation between arsenic contamination in the midstream Rishi-Bukto catchment, which has been increasing throughout the 20th century to a peak in the year 2000 before a decline, which very roughly parallels the human population occupation of that catchment. Arsenic has been used, among other things, in anti-fouling agents used in boats and navigation. So it could vary, and since the cocaine is heavily used by navigation, it could very well indicate a contamination of water and sediments through the increasing use of anti-fouling agents.